Okay, I want to show you two pinwheel programs. This is the second one I'm going to show you, so let me show you the first one here. And so this one has starts with an import turtle, and then there's a main which takes some parameters, and then down here I run the main with the parameters to actually produce the pinwheel. So let's go through the main quickly. The main has one, two, three, four parameters. Remember, those are also called arguments, function inputs. N is the number of sides of the polygon. SE is the polygon side length. L color is the polygon line color. And then after each polygon, the turtle turns by 360 divided by this number. So the larger this number is, and generally picking an integer here is a good idea just to keep things simple. The larger this number is, the smaller the turn angle. Okay, so um, some just contextual things first. We set up a turtle screen. We set up a background color. I chose Azer. It's kind of a subtle light blue. Give the screen a title. Test makes a pinwheel. Um, Set up the turtle that we want to use, which is Tess. Um, Telling Tess to meet its speed to move at speed 0 is makes the drawing quite a bit faster. I'm going to choose a somewhat larger pen width than normal, 7, and I'm going to give um, Tess a line color of L color. So L color is the line color. So the turn angle for the polygon is 360 divided by n. So when I make the polygon, which I do in this inner loop here, the turn angle is 360 divided by n, and the polyrotate angle is 360 divided by m. So this is the angle by which the polygon rotates after the polygon is made. And so there's a loop inside of a loop. This is a nested loop. The outer loop is the J loop, and this is the one um, that um, that the polygon loop is inside of. Okay, so this inner loop is the one that draws the polygon itself. So this is very simple. Basically, it goes through n times because the polygon has n sides, and we tell test to go forward whatever side length we specified, and then test turns left. You could also do a right here by turn angle, and so that's this 360 divided by n. And so after each polygon is drawn, test rotates polyrotate angle, that's this 360 divided by m, before going back and going through the outer J loop again. Okay, and so what I'm doing here is I'm defining a main, and then down here I'm invoking the main with n equals 3. That would be a triangle, a side length of 200, a line color of blue, and an M of 15. And so to see what that corresponds to, we could go over here and we could go 360 um, divided by 15, 24. Incidentally, I forgot to mention this in the beginning. I'm using the PyScripter um, IDE. And that's this logo down here. I don't know if that's getting captured in the video. Probably not. So this is the one which unfortunately just works on the PC. Um, so it'll work identical in your idle, but some of the nice features here is that, see, I have line numbers here. I've got kind of an integrated, well, here's the shell and here's the editor. It's kind of all put together here. And you can scroll here, and you can also scroll here. I don't have enough in here to scroll, so it's a little bit handier. Okay, so let's give this a run. And so in PyScripter, to run this, um, in idle, of course, you just type F5, but I'm going to click this. There you go. For some reason it hangs up when I do a video. Okay, so I'm going to kill the screen, and then I'm going to go over to the pinwheel program. Now this is going to be a little bit hard for you guys to understand, but give it a try anyway. So this is actually a better way to program. So what I do is I have a polygon program which draws the polygon. And then I've got a pinwheel program which uses the polygon function. And so it's more modular. So this function draws the polygon, and the pinwheel program, here's the polygon right here, and then here is the range M loop. And so the way this works is that, of course I import turtle at the top, that the polygon function has to have a turtle as an input, the way it works here. And these other inputs are just what you're used to. The number of sides, the length of the side, the line color. Poly pinwheel has the parameters you're used to, n, size, line color, and m, but it also has a turtle input. And then down in main now I use both of these, and so inside main I do again the context setting. I set the screen up, and then I define test to be the turtle. I give the line width a 6, just a little bit wider than normal, and then this is for fast turtle speed, and then I call poly pinwheel, telling poly pinwheel that I want test to be the turtle that does it, and so the T that you see here will become tests here and here as well. And when polygon is called with tests, again, every time you see T, tests will be inserted in there. And so this is cool because if you look at this function right here, it's like there's no nested loop anymore. And so you have the loop to rotate the polygon, but then inside that you just have this polygon thing. And so there actually is a nested loop because the polygon itself has a loop inside of it. But it seems to disappear the way you write the function here using polygon. Okay, so let's give this a run. This does you can see what I'm doing here. I'm making a triangle with length side of 200, red line color, and a turn angle of 30. And so that would be half this turn angle would be 12 degrees, in other words, if I did this. Okay, so let's go ahead and run this, show you what happens. Alright, so there's that. Okay, now I'm going to kill this and show you something else here. So what we're going to do is I had some lines that were commented out, so I'm going to put them back in again. I'm simply going to backspace here and backspace here. Alright, so what's this going to do is it's going to do the same pinwheel that I did, and then when it finishes doing this the first pinwheel, it's going to, the turtle test is going to rotate left by 6 degrees, which is half of the turn angle that we used here, the poly turn angle, I mean rotate angle, and then it's going to make a second pinwheel that's blue. Okay, and so can you see what this is going to do? Perhaps you can stop the video at this point and see if you can just conceptually understand what this and that will do. And so here we go. I'm going to run it, and let's see what we get. Okay, that's the red one. And here's the second blue one. And the fact that I've rotated half of this angle to start the blue one means that when Tess does the second pinwheel, it's offset from the first one by half of this angle. Well, this angle is 12 degrees, so there's a 6 degree poly rotate angle there. Okay? Okay.